Now we're looking at some problems involving working with vectors. So this first problem, they give us a vector in ij form, and they want us to find the magnitude. So once again, the formula sheet has some equations for vectors, right? Here's the magnitude, here's how you find the angle, to go back and forth between rectangular coordinates, ij, and magnitude and direction. So we'll be using those formulas. So this first one, so the magnitude is the square root of the x squared, which is, we think of the I like the x part, and the j like the y part. So the I part is minus 12, so minus 12 squared. And the j part is like y, so 5 squared. So this is 144 plus 25. Looks like it's 13. So pretty straightforward calculation. Here's another one. Oh no, not the same one. So they give you two vectors, v and w. And they want to take 3v plus 4w. So this is not difficult. So 3v means 3 times the v vector. I'll write it like this. Plus or minus 6 times the j, sorry, wow. It's down here, 4 times the w vector. So plus 4 times the w vector, which is minus 3i plus 2j. So when you do that, you end up with 12i minus 18j plus negative 12i plus 8j. Then if you combine like terms, 12 minus 12 is actually 0. So there's no I part. Minus 18j plus 8. If I didn't mess up, it looks like it should be minus 10j. All right, let's see what we have next. Write the vector v in the form ai plus bj given its magnitude and the angle it makes with the positive x. So here now they give us a vector v with magnitude and direction, and they want us to rewrite that as ij. It's pretty straightforward because x equals the magnitude times cosine of the angle, and y equals the magnitude times the sine of the angle. They probably want exact answers. Yep, they say exact answers. So x, magnitude's 5 times the cosine of 45 degrees, which is square root of 2 over 2. So 5 square root of 2 over 2 looks like x. So y is going to be magnitude times the sine of 45 degrees. Oh, yep. Be careful, these are both in quadrant 1. So It's actually going to be the same thing, 5 square root of 2 over 2. So 5 square root of 2 over 2I plus 5 square root of 2 over 2J. Then 25, here's a vector V. They want to know what the direction of this vector is. So I assume that's based upon the positive x-axis. If we just do a rough sketch of this, this is like I is a negative number and J is positive. Must be over here in the second quadrant somewhere. So they want to know this angle. Well, the way you find the angle is y is the j part, so it's 12. X is the I part, negative 12 square root of 3. So now you're asking yourself, is there a special angle where the tangent's negative square root of 1 over 3? Well, of course, we know this has to be in quadrant 2, which is good because the tangent is negative in quadrant 2. And this, once again, we've done this many times before where we have our square root in the bottom of a fraction. And that's going to occur at those angles where we have this kind of thing. So this is where the cosine is square root of 2, the sine is 1/2. And in this quadrant, that occurs at 5 power over 6. 5 power over 6 is where the cosine is negative square root of 3 over 2. The sine is 1/2. When you cancel it down, that equals negative 1 over square root of 3, which is what our tangent has to be. So, oh, they want it in degrees. So pi of 5 over 6 radians in degrees, I believe it's 150. That's what 5 pi over 6 is. All right, we have one more vector problem. I'm going to hold off on it for the next video because it's a pretty involved problem. So we'll stop for now and pick up 26 on the next video.